Hello friends, today we are going to talk about Traceroute or Traceroute. It's a very simple basic troubleshooting tool which every network engineer must know, every IT engineer must know about this tool, the use of this tool, limitations of this tool and how we can use it smartly. So let's get started. So first of all, what is Traceroute? So basically, tracer is a Windows command, okay, which we use a tracer from the command prompt, and a trace route, which is basically used from the Cisco or other network devices. Okay, so tracer and trace route is the same thing, just command syntax is a different. That's it. So in a computing, traceroute and traceroute are computer network diagnostic command for displaying possible routes and measuring transit delays of packets across an internet protocol network. So that's a basic definition of the traceroute. So in this, traceroute, how we can use that traceroute. So let's start with the example one. So here you can see if we have a machine and we have two different ISPs, right? How we can define which path actually it uses or which ISP it is using to reach the internet. Or this is just an example. We may have some private links as well, right? Or there are multiple paths, okay, and we need to find out which path actually we are using to reach the destination. If that destination to reach the destination having multiple paths, then which exact path we are using to reach that particular server or destination. To find that, okay, we are using that simple tool that is called a trace route, okay, or tracer. Okay, so also it also shows the delays, right? Hop by hop. Suppose you are in a machine in a LAN network, right? And you are tracing something, google.com or something which is hosting on internet, okay? And you want to know which path actually to do it. You just need to do trace, so it will show it is crossing the R1 and it's crossing the R2, like in the path it will show that 2.2.2. Okay, so it means it's going with the ISP1, right? It will also show that what is the delay between the each hop, right? What is the delay between your machine and your gateway? Then what is the delay between R1 and R2? Each and every hop it shows the actually delay, okay, which is in microseconds. So obviously it shows that, and you'll get to know, if there is a latency or there is slowness, how you can define where is the actual issue, right? So that is the first use of trace route we can use. Second thing which you can use, if you are doing a trace route, okay, or suppose something there is wrong with your network, the destination is unreachable but you don't know where it's getting stuck, okay? Suppose there's a route missing or someone is blocking, or something is happening between the path, then how you can define where exactly the issue is, right? So to identify that, you can use the tracer, okay, and you can see the whole path. If you know your your path to reach the destination, okay, what is exactly path and how many devices are in between, okay, which you are controlling, right? And if there is a particular device, after that the trace route is not going forward, then you can identify that particular device where the issue is, right? So you can just go to the device, or you can just ask the owner of the device, and you can just check what exactly going on there and why the traffic is not moving through that device, why it is not passing my trace route traffic, right? So this is the one use case where you can use, like here you can say it's my host machine is tracing 8.8.8.8. So this is something Google DNS server, right? And now here you can see before reaching to the 8.8, there is a one hop 142.250.214.101. Suppose if I block 8.8.8.8 on this firewall for this particular machine, this traffic will not able to cross the firewall, and it will show the last hop will be 142.250.214.101. So once I get that IP in my tracer out path, I can just ask the that particular owner why it is not moving forward, right? So this is the one troubleshooting use case which you can use here. Now we can see also there are some limitations of Traceroute. That is, first is not all the devices permit tracer traffic, right? Tracer or Traceroute. This is again, this is unnecessary traffic in some production environment. This is useless traffic, right? Where they are, you know, blocking that Traceroute traffic, only permitting something like only applications port number or application based access they are providing, so they are blocking this trace route traffic, right? So it doesn't mean that application, if you are not able to trace it, it doesn't mean that you will not able to access that application, right? So same like ping, they can block the tracer traffic as well, right? Again, not all the devices shows itself in a trace. Now if you can see here, there are numbers of devices, 7 devices if you can see here, but it doesn't mean that there are only 7 devices in between this path, right? There may be more than 7 devices are present in the path as L3 devices, but they are hidden. Okay, they can do that. They can just bypass their own presence in the path, okay, just for a security reason, so no one can identify their device in the path, but still you will be able to cross the device, okay, but you will not able to identify what was the IP of that device. This is normally happens in a MPLS, normally in a MPLS, in a private network. There are hundreds of devices in a network, okay, but to reach the destination they just bypass their private MPLS network, right? You will be able to see only your network, right, and directly your destination, okay, but they bypass all their internal network devices, okay, so you will not able to see their devices or their IP addresses, right? This is again for security reasons they do like that. Again, there's a limitations with the maximum 30 hops, right? You cannot go beyond 30 hops as per the Windows by default, Windows, where you can maximum, if the device is far from more than 30 hops, you will not able to complete your trace, right? It will automatically drops after a 30 hops. So this is a limitation with the trace route. So how you can use it, the Traceroute or Tracert smartly, right? So in a private network, so definitely you can use a Tracert because in a private network, everything in a control, right? Everything is in control. You know which device is blocking, which device not, because all the devices you have control over there, and it makes sense to use the Traceroute, okay, a simple basic troubleshooting tool in your network, right? It's a great tool to know the actual traffic path, even though in a internet-based links, right, where you can see the actual path which ISP currently you are using with the help of Trace, right? This is also a great tool to identify the delay between the hops, right? Uh, Oh, in the ping, you just able to see the overall delay, right? But in the overall delay, which exact hops actually, are responsible for that delay, you will be able to identify with the help of Traceroute. So you will be able to see if there are 10 hops, but a particular hop is actually utilizing a more delay, right? So there is something issue between those particular hops. Maybe link is utilizing, maybe the CPU utilization high, maybe any other reason will be there, but we can identify those issues, right? Also, we can identify the best path in various available routes. So if to reach the destinations, if you have a multiple ISPs, so you can just test by tracing all the paths. You can just change the routes and see which path is uh, you know uh, better for your environment, right? So based on the trace or latency and lower hop counts, you can decide which path is um, best use case for you. Some routing protocols are automatically detects that, and they make best route based on their algorithms, okay, automatically for you. But if you have a static routes, or you need to decide which path is best for you, you can use the trace route and you can do that. So in a summary, it's a simple troubleshooting tool. It's a very simple troubleshooting tool. You can just open the command prompt, or from a router switch, you can just to identify the path. Just need to trace and a destination. You can use a source if whenever required, and do that troubleshooting. It's a very simple tool. Understand its limitations. So already we discussed that there are limitations. Not all the devices permits you know trace route traffic, or make themselves available, or make themselves presence uh, in the traffic path. They are just hidden. So whatever the trace route path you are see in the internet, or which is not in your control, you can't be sure that that's the actual path, right? Maybe there are some hidden devices also present in that path, right? Also, there are some smart use cases where you can use the tracer smartly. Okay, if you think you have gained some knowledge from this video, you can just like and subscribe for this channel. Thank you.